final example for the basic integration. So for the final example, we have here, so for number 7, we have here the integral of 6 over x cubed minus 2 over x dx. So just like the previous example, all you have to do is to put this to the numerator. We write this one, so as 6x raised to negative 3 minus, so as you can see, it's 2x, right? So it simply can be integrated as ln x. So 2 ln x plus c, and plus c. Wait. Let's just copy this one because we're not yet integrating. We're just rewriting this one. So just copy 2x dx. So now let's integrate this example. So we have here 6x minus raised to negative 3, then add 1, then copy this one. So minus the 2x, so it will become a ln x. So ln x plus c. So simplify. So 6x negative 2 over negative 2 minus 2 ln x plus c. Divide this one. So negative 3x raised to negative 2 minus 2 ln x plus c. So this is the final answer. So that will be the final problem for the basic integration. Okay, now let's proceed to the use substitution rule and integration. So use substitution rule is the undoing of chain rule. And the process in doing use substitution rule is first is to look for the inside function in the original function. So the inside function will be our u. And then when we already found the inside function or our u, then we are going to derive the u. After deriving the u, then we are going to look for the vx. Now for the inside function or our u, in looking for the u in the original function, all you have to remember that u can be found inside a parenthesis or let's say function that has exponent, or function in a radical, or even in the exponent of a term. For example, x raised to 4x minus 7. This 4x minus 7 will be our inside function. So, for example, let's use this 4x minus 7 as an example in looking for the u, the du, and the dx. So if we already have the inside function, then let's 4x minus 7 be the u. So 4x minus 7. Then we are going to derive the 4x minus 7, which is, it will be now a 4. Then copy the dx. Then let's have the dx. Then divide this one with the du. So we now have a du over 4. And once we already solved the u, the du, and the dx, we are going to substitute these terms to the original function. So that's how use substitution works. For example, we have here the integral of 5 times z minus 4 times the cube root of z squared minus 8z with respect to z. So following the steps, let's look first for the inside function. So it's very obvious that our inside function is the z squared minus 8z, because just like what I've said earlier, inside function can be found in a radical. So let u be the z squared. Okay, let's write this one here. So we have our u, which is z squared minus 8z. And now we are going to derive this inside function, which is become 2z minus 8. Because minus 1, then 2 times 1 is 2, then minus 1, so it can be 0, then 1 times 8 is 8, right? And then you have to write the dz, then look for the dz, we solve for the dz. So our dz will be du over 2z minus 8. Now that we have these terms or these functions, we are going to substitute this to the original function. So let's rewrite this one. So copy the 5 times z minus 4z. And then we have to substitute this one to the variable of u. So copy the u, then don't forget the exponent. So we all know when we interchange this one, and when we change this one into exponential, it becomes raised to 1/3, right? So copy the 1/3, and then substitute the value of the dz, which is du over 2z minus 8. So we have here du over 2z minus 8. So let's erase this one so we can have bigger space. So now that we already substitute the u, the du, and the dz, let's look first if we can factor out or we can cancel out a function or a term. So as you observe, if we multiply this term and this term, we can factor out a number and we can still cancel out. So let's multiply or combine this first. So we can have now a 5 times z minus 4, then multiply this one, which is over 2z minus 8. Then copy the u, so u raised to 1/3, then the du. And as what you can see right here, we can factor out this term. And once we can factor out this term, we can cancel out the z minus 4. So it will become the integral of 5 times z minus 4 over, as you can see, it is divisible by 2. So 2, then 2 divided by 2 is 1. So we can now have only the z, then 2 divided by the 8, I got it 8, so we can have the 4. Then copy du. Now, as you can see, they are the same, right? So we are just going to cancel this out. So 5 halves will be left right here. So we will now have the integral of 5 squared, copy the u 1/3, then du. So now we can integrate this function. So we have here, remember that this u raised to 1/3 is beside the 5, right? So if we add 3 over 3 or 1 in the 1/3, we are going to multiply this to the denominator, which is the 2. So we have here 5 u, then when we add 1/3 plus 3/3 is 4/3, right? Then the 4/3 will be multiplied to the denominator, 4/3. Then instead of writing the du, we're just gonna add c because we are already integrating the function. So now let's simplify this form. So this function, so it will become 5u 4/3 over 4 times 2 is 8, then over 3 plus c. And then for this to not be a fraction, we are going to multiply it by its reciprocal, which is 3 over 8, right? So when we reciprocate this one and multiply this, it will become 3 times 5 is, let's just write this one right here. So it will become 15 over 8, then copy the u 4/3 or raised to 4/3 plus c. And once we already have this answer, the u, we are going to substitute this with the value of the u, or the inside function. So it will become 15/8, our u, which is the z squared minus 8z raised to 4/3 plus c. And this is our final answer, or this is the integration of the integral of 5 times z minus 4 times the cube root of z squared minus 8z with respect to z. So let's have another example. So for our another example, we have here the integral of 7y minus 2y cube times e raised to y raised to y raised to 4 minus 7y raised to 2 dv. Now, I'm looking for the inside function. As you can see, this e has an exponent of a function, right? Which is y raised to 4 minus 7y raised to 2, or 7y squared, which is this will be our inside function. So let u be the y raised to 4 minus 7y raised to 2. Then derive this one, so it will become 4y raised to cube, or 4y cube minus 14y, then copy, this is dy, I'm so sorry. Then copy the dy, then look for the dy, which is du over 4y cubed minus 14y. So now that we have these terms, we are going to substitute this one to the original function. So we have here, copy the 7y. So let's just copy the 7y minus 2y cubed, then e, then change this one into the u, which is u, then the dy, which is du over 4y cubed minus 14y. So let's erase this one. So now that we have this function, so if we multiply this term and this term, we can still factor out and cancel. So instead of writing this one, as you can see, this term is the same with this one, right? Because they have the power of 3. So we just gonna interchange the 4y cubed minus 14y into negative 14y plus 4y cubed. So remember to not forget the original sign. So we have here, if we rewrite this one, we're gonna have 7y minus 2y cubed over negative 14y plus 4y cubed. 4y cubed, then copy the e raised to u, then the du. And for this term, we can still factor out, which is we can factor out this by negative 2. So we now have the integral of 7y minus 2y cubed, then factor out by 2, so negative 2, so it will become 7y minus 2y cubed. Then copy the e raised to u, then the du. And as you can see, we can now cancel this term. Cancel, cancel. So the only left is negative 1/2 because it has 1 right here, but it's visible of 1. So let's rewrite this one. So it will become the integral of negative 1/2 e raised to u du. And you always have to remember, just like what I've said earlier, that u cannot be integrated, right? So you just gonna copy this function, which is negative 1/2 e raised to u plus c. And then we are going to change the u with the value of the u, right, which is our inside function. So now it will become negative 1/2 e raised to y raised to 4 minus 7y squared, then plus c. And this is our final answer. This is the integration for the integral of 7y minus 2y cubed times the e raised to y raised to 4 minus 7y squared with respect to y. Okay, now let's proceed to our last example for the u substitution rule. So we have here the integral of sec squared v times e raised to 1 plus tan v with respect to v. So obviously our inside function will be the 1 plus tan v. So we have here our inside function. So let u be the 1 plus tan v. And then derive this one. We all know when we have a constant, it is equivalent to 0, right? And the derivative for tan v, or the tan itself, is secant squared. So it will be secant squared v, then copy the dv, then dv is equal to du over sec, or secant squared v. Now that we have these terms, let's substitute this one to the original function. So we have here, copy the secant squared v, and then the u, and then substitute this with the variable of u, then the dv, which is du over sec squared v. And as what you observe, if we multiply this term and this term, we can cancel this out. So it will now become sec squared v over this term, which is sec squared v, then copy the e raised to u, then the du. Then we cancel this out. So we will now have the integral of e u du. And just like what I always says, e cannot be integrated. So just gonna copy this one. So e u, then change the du with the plus c. Change the du into c, which is plus c. And then now that we have this e raised to u plus c, we're going to change the u with the inside function, which is e raised to the 1 plus tan v plus c. And this is the final answer. This is the integral or integration for the integral of sec squared v times e raised to 1 plus tan v with respect to v. And that will be all. And that's how you solve integration. Thank you.